Oh, I wasn't recording. That really is a bummer. That really is a bummer. So I'll just run through what I did. So what I did was in 227, the acceleration is minus 9.8. So I just said the acceleration is minus 9.8. And then I used the integration formula that velocity is the integration of acceleration. So if you integrate minus 9.8, you get minus 9.8t plus a constant of integration. The constant of integration is to make sure that when the velocity is 0, we get 40. So the constant has to be 40 because this guarantees that v0 is 40. To get the height or displacement, we have to integrate velocity. So in other words, we have to integrate our previous answer. And integrating this answer, we get minus 4.9 t squared, because it's increased the power, divide by the power. That becomes 40t, and then we get another constant of integration. And that's to guarantee that the height at 0 is supposed to be 1.5. So it's quite a simple, quite a short question. I also imposed this extra restriction on the time because it gets a little bit funny about what happens after the ball hits the ground. And I got this number here by just getting the roots of the quadratic for the height. So if you want to, you can put this restriction on it. And then I simply remarked that 228 was practically the identical question, the only difference being the initial height and the initial speed. And that would only have the effect of changing the constant of integration in our answers. So essentially the same question was the point I was making. So unfortunately, the video didn't record, but hopefully that's clear enough for you. And that ends the batch of velocity questions, and it moves on to a different type of question in the book.